All right, so for part 2 of this, we're going to do them without a common base. So here we have 6, so 2x minus 10 equals 36. And so we need to make the 36 so that it has a base of 6 with an exponent. So we're going to keep this 6 to 2x minus 10, and then we can make this 6 squared. And so now that we have the bases of 6, we can set the exponents equal. So we have 2x minus 10 equals 2. So we add our 10, so that we have 2x equals 12, and then divide by 2, so x equals 6. So our answer is x equals 6. Now for number 6, we have 4 to the 3x equals 8 to the x minus 1. There isn't a way to make 8 have a base of 4, so we need to change both of them so they have a common base. And they have a common base of 2, so we're going to make 4 into 2 squared. We're going to put that in parentheses, and then put the 3x on the outside. And then we're going to make 8 into 2 cubed, and put the x minus 1 on the outside of that. Right? And then now that we have a base of 2, we have to figure out what to do with the exponent inside the parentheses and the exponent outside the parentheses. And when we have a power raised to a power, we multiply them. So this becomes 2 to the 6x equals 2, and then we're going to distribute this. So we have 3 times x, which is 3x, 3 times negative 1, which is minus 3. So now that we have those have a common base, we're going to do 6x equals 3x minus 3, and then you're going to subtract 3x, so that we have 3x equals negative 3, and divide by 3, so x equals negative 1. Right. So for number 7, we have 7 to the 4x plus 11 equals 1/7. So we need to make 1/7 into a power with a base of 7. And because it's a fraction, we know it has to have a negative exponent. So it's 7 to the negative first power. And then we're just going to bring down 7 to the 4x plus 11. And now we can set them equal, so that we have 4x plus 11 equals negative 1. You're going to subtract 11, so that we have 4x equals negative 12, and you divide by 4, so x equals negative 3. Right. So number 8, once again, we have 2 numbers, and they don't have a common base between them, except for making them both have a different base. So that base is going to be 5. So 25 is 5 squared, and 125 is 5 cubed, and then we still have to bring down that exponent to y. Remember, if you have an exponent inside and outside, you multiply them, so this becomes 5 to the 3y equals 5 squared. And now we can just set the exponents equal, so that we have 3y equals 2, and then divide by 3, so y equals 2/3. And that is the answer for that. So for number 9, we have 81 to the 2x plus 5 equals 1/3 to the 2x. So we have to get them to a common base, and that common base is 3. So 81 is 3 to the 4th power. So we make that 3 to the 4th power to the 2x plus 5 equals, and then 1/3 with a base of 3 is 3 to the negative 1st power to the 2x power. All right, so we have our exponents that we need to multiply now and distribute this side. So we have 3 to the 8x plus 20 equals 3 to the negative 2x, and then we can set them equal and solve. So we have 8x plus 20 equals negative 2x, and then we just subtract 8x from both sides, so that we have 20 equals negative 10x, and divide by negative 10. So we have negative 2 equals x. That is the answer for that one. right, so for number 10, we have to deal with this 4 here. And when it's not given an explicit exponent, it's assumed that it is 1. So we have 4 to the first power times 4 to the 4x power. And since we are multiplying, we're going to add them together. So we have 64 equals 4 to the 4x plus 1. Right? And now we need to make 64 have a base, a common base with 4, which it is 4. So this becomes 4 cubed equals 4 to the 4x plus 1. And now that they have common bases, we can just go ahead and set them equal. So 3 equals 4x plus 1. And we can subtract the 1. So we have 2 equals 4x and divide by 4. So 1/2 equals x. All right. And then for number 11, we have several bases here that we have to condense. So 1/7 we need to make to 7 to the negative first, like we did up here. And then 49 with a base of 7 is 7 squared. So we're going to make that 7 squared in parentheses. Then times 7 to the x minus 9. All right, so before we can start adding our exponents over here, we have to multiply this. So that becomes 7 to the 2x minus 10 times 7 to the x minus 9. And we still have 7 to the negative first over here. So we're going to add our exponents. So 2x and x is 3x. Negative 10 and negative 9 is minus 19. And now that we have the same base, we can set our exponents equal. So we have negative 1 equals 3x minus 19. And then we can just add the 19. So we have 18 equals 3x. And then we're going to divide by 3 so that x equals 6. We'll just ran out of space there to write the division. All right, and then number 12. So we have several bases here, but it looks like 4 is our common base. So we're going to keep this 4 to the 2x. And then we're going to change 1/16 to 4 to the negative second, because 4 squared is 16, and then the reciprocal of that needs a negative exponent, equals 4 to the 6x plus 18. And then we have our common bases over here. So we're going to add the exponents. So 4 to the 2x minus 2 equals 4 to 6x plus 18. And now that we have our common base, we can set our exponents equal. So we have 2x minus 2 equals 6x plus 18. And just to save some space, we're going to subtract 6x and add 2 at the same time. So we have negative 4x equals 20. And we're going to divide by negative 4. So that x equals negative 5. All right, we're down to our last couple of questions here. So 13, we have 32 equals 2 to the 2m minus 9. So 32 does have a base of 2, and that is 2 to the 5th power equals 2 to the 2m minus 9. We have our same base, so just we can set them equal. So that we have 5 equals 2m minus 9. And then we're going to add our 9. So we have 14 equals 2m. Divide by 2. And we have 7 equals m. All right, and then the last one. We have 8 to the 2a minus 1 equals 32 to the 2a plus 1. Right, so 8 and 32, we know they have common base of 2. So we're going to make 8 2 cubed to the 2a minus 1. And then 32, we just said in the previous problem, is 2 to the 5th power to the 2a plus 1. And then this is where we're going to multiply our exponents and distribute it. So that we have 2 to the 6a minus 3 equals 2 to the 10a plus 5. Now we have a single common base, so we can set our exponents equal to each other. So 6a minus 3 equals 10a plus 5. All right, and then we'll subtract 6a and subtract 5 at the same time. So we have negative 8 equals 4a. 4. So that negative 2 equals A. And that's our final answer.